He is the professor and head at the Computer Science and Engineering Department at CBIT, and he is also an IEEE senior member. He previously worked as a senior software engineer at Low Touch Technologies and as a professor at Vardhaman College of Engineering. On this note, I hope that this session will be informative and enlightening. On this note, I'd like to hand over the stage to Dr. Raman.
Yeah, good evening, all. Madam, am I audible to you?
Yes, sir.
Yes, sir.
Okay, 1 minute. I am going to share my screen. Is my screen is visible?
Yes, sir.
Okay. Is my voice is clear? Hello.
Yes, sir.
Shall I proceed, madam?
Yes, sir.
Yeah. So, good evening, one and all. I'm Dr. Raman Dugyala. So, thanks for your introduction. So, I myself worked as a professor in Department of Computer Engineering, CBIT. Previously, I worked in different organizations. Almost I have 24 years of experience in teaching. 2 years I worked in industry, that software industry, as a senior software engineer. It's my pleasure to take a session, audience, faculty, community, faculty, also the other industrial experts, colleagues, and many other participants, the research scholars. So, yeah, so the today's virtual FDP program, I got a request to discuss about mobility as a service, principles, platforms, and business models. So, my agenda points are the urban mobility challenge. The first, I have to discuss about the importance of MaaS in urban area and what is the MaaS and its core principles, the MaaS ecosystem and key technical enablers, and the role of IoV, and reconstructing the MaaS platform and its architecture and the components involved in the MaaS platform, evolving business models and value propositions, and I'll discuss about global case studies, the Indian context and global context as well. And also, I may enlighten you to go ahead to do your research and what is the roadmap for upcoming MaaS usage in India and even in the global as well, and the future directions related to that. Finally, session is ended with the question and answers. Okay, so what is the challenges we are facing right now in the market? We can see the diagram. It may explain you the different congestions and fragmentation, user friction. So what do you mean by fragmentation? The multiple unconnected transport models, such as bus, one transport model, metro, taxi, rickshaw, bike, these are all the different ways we may use the transport right now in the market. But the challenge in all cities of India is the biggest challenge is traffic congestion. When some rainfall, at least for 10 minutes rainfall, there may be a lot of water in the roads. We cannot move aside. All vehicles are stuck. Roads will be very narrow, and it may leads to lot of traffic. Recently, even when I am coming to my college to my home, I heard that one news. One of our faculty, she thought that the traffic is very heavy, so she may ordered samosas to all the faculty in the bus. They had their snacks in the bus itself to reach their home. So that is the situation where we are living, and there is a lot of traffic, and we have a lot of transport models, but that that may not integrated. That is why we are facing a lot of problems. Yeah. What I want to convey here is somebody may go through bus and he want to catch the metro train, but there is no connection between your bus stop to metro. And also, if you can catch the metro from there to reach your destination, after getting down from the metro to your location, there is no connectivity. And even at the time, if you want to book a auto or a bus, or if you want to book some bike or something else, because of heavy peak time, because of peak time, you cannot get the the vehicle immediately. May delayed for 1 hour. You thought that you may get, but because of peak time you may not get. That is why you are facing a lot of problems. These are all happen because of fragmentation, because there is no connectivity between the transport systems, private and public. Public transport system we have, private transport system we have, but there is no connection between that. And to pay, we may use GPay, and we may use a cards, we may use some other ways, QR code connections. A lot of things we can use, but that also not having the uniformity. So these are all the problems we are every day we are facing. And from 2019 onwards, the technology got involved, and they start working on MaaS, so mobility as a service. So we are now in the era of getting services. So we are going to get a service, and we may subscribe, we may get a service. So that is the world we are right now. So the researchers decided, they thought, they developed a platform where you can get all the connections, and it may solve you the fragmentation problem. And when it comes to inefficiency, low vehicle occupancy, traffic congestion, and high emissions. The meaning of low vehicle occupancy, recently the Telangana government 1 year back, they started giving free to all the women, but still women facing a lot of problem while taking the transport through RTC buses, because the capacity is because everybody coming, because of it is free, everybody is coming and using the opportunity. That is why huge traffic, huge, the occupancy is very less. That is why they are facing a lot of problem in bus. So can anybody will tell what is the solution for that? See, everybody want to use the transport system, public transport system, because of their packet supports and their revenue, their revenue demands. All these things they are using the bus facility, but there is a lot of congestion, and because of less seats in the bus. So is there any solution for that? Can anybody, audience, can anybody will give a solution for that? What could be the reason for that congestion, and more women in the bus? They are unable to get a seat. They are standing, they stand at almost more than 2 hours in the bus. Okay, so they have a lot of problems, so they cannot handle that complex situations. Still we are facing a problem in the transport system. Is there any solution for that? Why can't you give this as a project to your BTech final year students? Think about it. Then you have another topic, traffic congestion. So every day, if you go and see some critical areas like Mehdi-Patnam or some other areas, everywhere, I think now everywhere there is a lot of traffic. Flyovers are constructing, so roads are very narrow. People are facing very difficulty to reach their homes and their destinations. And when you are in that traffic, a lot of carbon emissions. Okay, so that may leads to so many diseases, asthma and all those things. Your respiratory tract may affected if you can stay 2 hours in a traffic. So these are all the challenges right now every human being is facing in urban areas. This is not the problem in rural areas, but it's the problem in the urban areas. And user friction. So separate tickets, different apps, unclear pricing, poor planning. I want to go to my destination with 2 to 3 models. Like first, I'll take a bike. I kept in the metro station. Then I take the metro, and from there I'll get on there. Again, I'll take book a cab. If you can see, to reach the destination, we are using different models for everybody. I have to pay in different aspects. Somebody may ask cash. somewhere I can use ticket in the metro, I can use in my card because I am getting a concession. If I am a regular employee, regularly using the metro, then I can get a concession. That's why definitely I'll go with a ticket. After that, I get down there, I cannot get any vehicle. That's why I will book using some other apps like Ola, Uber, something like that. And also, poor planning also plays a vital role. So these are all the problems right now the urban areas are facing. So the mobility is a challenge. Now I am what I want to convey. We are all, including me, everybody is facing problem. See, even you have a car, you cannot reach your destination properly. You have very good AC, you have a good car, but time is the factor. You can't reach your destination if you go in a direction where the traffic is very high. So these are all the right now the every society, urban society is facing the problem. For you all, the question is how do we move from a system of a separate modes to an integrated mobility network? So what is the integration required here? How to address this problem? So that is what I want to discuss today with you all. So first, before going to start my session, the previous session for all the challenges, the solution is MaaS. MaaS means mobility as a service. MaaS is the integration of various transport services into a single on-demand mobility service accessible through a unified digital channel. If you can see this diagram, this is a mobile where we can plan, we can take a bike, we can take a car, we can take a bus, whatever you want, you can take. But everybody, the users of all these models will use a single app. If you can able to develop an application where it will provide a solution to all my problems. Using this mobile, I can plan my journey. I can identify the less trafficked regions using data science or AI models, and I can get a card, digital card. I can use the card to pay, and it's very transparent based on the time, based on the distance, so based on the spending time in the traffic. The rate will be varies, and it is unique, and you may not get any poor planning. So all these will be solved directly through an app. So that app will help us and it will provide us services which will solve all the challenges right now what is the society is facing. So the major core principles of MaaS integration, bundling public and private transport options. Here the challenge is how to club the private agencies with the public transport system. So we have to come up with a solution in the form of a software or a digital platform where the both the parties will collaboratively solve connecting to a digital payment system, and both the parties will get a credit once you pay into that account. So that is what we are going to plan. And user centricity. User centricity means we can plan the journey, we can book advance, and we can do payment and the ticketing in one place. You don't need to get a ticket everywhere. So the user centricity is another principle. Then personalization, offering plans and options based on user needs. As already discussed with you, because your journey is very often it may not need plans, but every day you are going to your offices and if you know the journey early, you can plan it properly, and if you going every day to day basis, you may get a lot of offers that will be very much useful to your finance as well. So the personalization is also a factor we have to consider to utilize the MaaS that services. And seamless payment, just a single payment for multimodal journeys. So no need to pay everybody. Sometimes there may be network issue, and sometimes maybe your internet is not support. Then you cannot pay to them. Then you have to think about your cash, or else you have to go to the ATM centers, get the cash, and hand over it to your auto wala, rickshaw wala, whatever it could be. So these are all the problems right now society is facing. So to all these problems, one solution is MaaS. So these are the basic and the core principles which are very much important to develop a MaaS. So basically, MaaS will solve integration of multiple transport services into one digital platform and seamless planning, booking, and payment. Focus on user-centric mobility. So to get an efficient, shared sustainability mobility, we are going to use the MaaS. So what are the objectives of the MaaS? The MaaS will enhance user convenience. Ultimately, with these objectives, MaaS is going to be implemented. It will provide convenience to the user and it will improve the urban mobility efficiency. You can move from source to destination efficiently and it will promote sustainability. It supports data-driven transport planning. In line with the smart cities, we may get a sustainable mobility and it will support smart city initiatives. Okay, the MaaS will support smart city initiatives because if you want to build a digital India, there smart cities are plays a vital role. In the smart cities, MaaS will support like anything. To become, in China, already they are using MaaS widely in all the cities. If you can see the overall aspects of the MaaS spectrum, MaaS is not a binary concept. It's a spectrum of integration. You cannot get, today it will be there, tomorrow it will not be, not like that. It is a combination of different layers, different levels. The first level is integration of information. Example, Google Maps. So where you can able to see the places where you have to go. I think you all know about Google Maps. I don't need to explain it. Integration of information is the first level. Once we have integration of information, then integration of booking and payment, the second level. Here, actually, um, Google Maps is an application involved here, and booking and payment, which is the applications related to the private agencies, that is what Uber and Ola. And level 3 is integration of services. So Vim and Move It, these are the global applications. In Finland, Vim application is used by public. They may not pay to anyone. All their mobility will happen with a single call. Okay. And if you can go and see level 4, we have integration of policy, that is subsidies and societal goals. So the government agencies plays a vital role here to form the policies to solve the problem of the public because public is facing a lot of problems. So what I want to convey from this slide is it is the integration of different levels of technologies and policy holders and private agencies and public transport systems. Everybody should involve and they are part of the spectrum. Without their involvement, support, and extension, we may not get a solution to the uh, current society. So this MaaS spectrum, it is from information to the subscription. Means what? You have to subscribe. Once you subscribe, you can get a service of Google Maps. You can get a service of Uber application. You can get a service of Vim application. You can get a service of policies as well. If you can use that system, you may get subsidiary and you can get, see, I may develop a application and this MaaS spectrum is prepared and it is ready to use, but public is not interested. There is no use of developing all these things. So how to attract people? For that, you have to provide subsidies and societal goals because it is not only support the urban area, it also supports the global society, global planet. Because if you can use the shared mode of transport system, automatically emission rate number of vehicles get reduced in the road. Already Delhi is planned alternative days. They are sending vehicles. That is a one model. It's a policy making. Because of the policy standard, the carbon emissions get reduced in that city. Like everywhere, in time being, in the coming future, you may have a lot of policies to survive the global planet. So to make it sustainable, we have to follow. These are all layers integrated, collectively work together to form a mass spectrum that is very much useful to the society to reach their goals. Then the core principles of MaaS is user-centric design, interoperability, and open standards. Because in all these layers, everybody follow their own policy standards. So all are should integrated. And sustainability is a major factor. We have to think about it. And inclusivity and the data privacy and security. When the vehicles are connected, when the applications are connected, there may be a chance of leakage of data, and there may be chance of access of privileges and security aspects, data privacy. These are all because one entity we are using, our data cannot be shared to the others. So identity theft also may happen. So we have to think about all these aspects. So these are all very much required for mass implementation. So you can see here the enabling technologies. These are the predominant technologies we have to focus to implement the mass. The first one is IoT and connected vehicles. See, here all applications are connecting and vehicles are also get connected because your data, you are using one X system and you are jumping to the Y system and again you are jumping to the Z system. In all these systems, application can get the data from all X vehicle, Y vehicle and Z vehicle. For that, vehicles are interconnected with IoT, Internet of Things. So there are different activators and sensors we may use. That sensors, activators will generate the data and that data will be shared to the cloud system. So if you are using your mobile, your GPS tracker is enabled, and your coordinates are get shared, and your traffic nearest traffic are analyzed, and all details are shared to the next system because that fellow who is going to catch you, he may be ready and he may plan his journey based on your previous data. So these are all happen if it is interconnected. All vehicles are interconnected, connected, and they are going to share the data. And to handle this data, we have to focus on big data techniques, and even we need AI. Why? Because not only a single user using this application, billions of users are using these applications because we are sharing it to both private, public partnership, PPP. So once it comes into the PPP, billions of users are accessing the data, and everybody's data get captured, and data can be stored, and data can be analyzed. So this is what big data. So the everybody's data will be stored in the form of a blog in the databases. Okay. So you may use RDD, recurrence data sets. We may use. Okay. So and also once data get collected, and we have to identify the biases, we remove the bias, and we have to apply the artificial intelligence techniques like KNN, robust regressions, blah blah blah. All are the different techniques we can apply, and we can visualize the graphs, and we can see if it is a traffic transport system, we can see the transit vehicle where it is and where it is transitly available, and what is the status of the vehicle, and all these things we can going to be captured and we can analyze. So big data and AI is the next level technology, enabling technology, which is very much used in the implementation of the MaaS. And cloud and edge computing. Cloud. See, here the name itself is a mobility as a service. So if you can pay, you will get a service. The clouds will provide a lot of services. If you can see Amazon Cloud, Google Cloud, and Azure, Microsoft's Azure cloud, wherever you can go, the clouds will provide a lot of services. It will provide AI as a service. It will provide data as a service. It will provide infrastructure as a service. It will provide, S3, AWS S3, storage as a service. So, and edge computing means the big data technique. Because of huge amounts of data, every transaction we cannot do in the core area. We may do the computing at local systems as well instead of sending it to the remote servers. Okay, so that plays a vital role to take a decision, because to handle the big data and to apply the AI algorithms, first you have to have a server to store the data, and the large infrastructure can be handled by cloud and edge. Then the applications, if we can see in our academia, IoT applications we can develop, and we share the data through clouds named as ThinkSpeak. Lot of clouds we have. So there we are going to importing a lot of APIs to develop the programs. Why? Because every application will have their own API and standard. So the applications are ready to extend the scope to the next application. So APIs will be downloaded and attached, imported, and will be used to develop the programs. Without that application programming interfaces, we cannot build the application. So APIs for interoperability, because everybody business is different, every vehicle standard is different. Okay, so for that here also we can use a lot of protocols to communicate data between different layers. Okay, so those protocols will have their own standard. So interoperability plays a vital role here. And finally, enabling technologies, the last one is digital payments. So we may use UPA or NFC codes or QR code, any mode we can use to do the digital payment. So this is about the technologies part with respect to the MaaS. So now you can see the ecosystem, the role of Internet of Vehicles here. Real-time data, vehicles as data source, location, speed, occupancy, and health. So vehicle condition, vehicle location, vehicle what speed it is coming, and what is the occupancy. These are all coming. These are the parameters. Don't limit it to that. There are a number of parameters, but an example I'm telling you. Every vehicle having the data sources. From that data, we are going to capture from the sources. We are going to capture the lot of data, and we get stored into the using the big data models. We can store this data, and we may use Sparks technology. Sparks is a it's a big API. It can be used to handle big data. Okay, and VTX communication, vehicle to everything, enables dynamic routing, safety, and traffic flow optimization. We have to focus on optimization techniques to reduce the traffic, and we have to focus on instantly based on the traffic, based on the congestion rate, and based on the peak time also a factor. Peak time we may plan, and dynamic routings are established automatically, and vehicles are get controlled. And safety, because the safety is also another parameter, it's very much important. So vehicle to everything, that is VTX communication. And predictive maintenance ensures service reliability. So whether we are getting a service reliable service or not, that will ensured. And always we have to maintain the system and applications regularly to get the predominant outputs. A user can connect it to the technology enablers. User may connect it to Internet of Vehicles. User may use the MaaS provider like an app or a platform, and user can use the transport services providers. User can depend on data providers as well. So interconnection of all these things, a users will get a convenient. So we are ultimately trying to make user convenient to utilize the mobility. Okay. IoE, Internet of Vehicle, provides the real-time connected nervous system that makes the dynamic and efficient masses possible. So please focus on this ecosystem. So we may have opportunities to work in different areas like IoE technologies and database management systems, and MaaS application implementations, and again the transport services. So this slide will enable you how to build an effective MaaS ecosystem and the role of the Internet of Vehicles as well. Then we come to next slide, reconstructing the MaaS platform. So if you can observe here, there are different layers. Basically, it can be divided into 4 layers. One is the data layer, where sources like GTFS, vehicle sensor, user data, traffic APIs. And the second layer here, data layer, these are the sensors will generate the data. So we based on a lot of activators or sensors in the vehicles, it will always sense the data and share it to the cloud. So these are the data sources. And layer 2, we have analytics and AI engine. So here I already discussed analytics and AI engine. Sparks is a latest software. It will help you to develop analytics. So the functions like route optimization, demand prediction, dynamic pricing, and ETA calculation. Okay, so these are all the different modules will help in the layer 2 to do the predominant analytics and rule-based engines. That is what AI engines, based on that it will works. And layer 3, service layer, that is API gateway, application program interface gateway, functions as booking, payment, identity management, and notification. So to book, booking is a service. So to book a ticket, we will have a application which it provides a service named as a booking. It will give you the availability and the price list and nearest locations, everything. And payment, after booking we reach a last page for a payment. The payment gateway will help you to use the model like uh, GPA or QR code. With that, we can go to do the payment. And identity management, whether the same person is doing the involved in the process or not, will be managed. And based on the credentials, like if you can supply your Aadhaar card, he may identify you. Then notification. Once the booking is confirmed, you will get a prior intimation through SMS or through WhatsApp messages or through mail. The notifications also a place better. So all these things are comes under service layer. That is what API gateway layer. Then we have presentation layer. This is very much friendly and look and feel applications and web portals we are going to develop here. It acts like an interface. The journey planner is one example, booking planner and payment lists and live tracking. So these are comes under presentation layer. So these are all the layers involved and performed and integrated, and it will give a total MaaS platform. So one platform, like I told you, Finland uses the Vim application. There it is a combination of all these layers. So if he can install that application into his mobile, he can do whatever he wants. So mobility becomes very easy. He can plan his journey, he can book the ticket, he can get all the services involved in the layer 3, and the look and feel the interfaces also he can enjoy. So that's about your structures, layer structure of a MaaS platform. So do you have any questions till now? Please, you can ask me. Because my session is static session till now. If you have any questions, please. So somebody asked about the journey. Yeah. Is it clear now? Hello.
Yes,
I
sir.
didn't see your message because I thought it is okay. So now it is clear to all of you.
Sir, one doubt is there. Can you elaborate on edge computing?
Yeah. Edge computing is nothing but see, I'll give you a simple example for that. See, edge computing means, see, computing will be happen in, see, we have a RAM and ROM in our operating system, right? So temporary results we can calculate, and we may use a level 3 cache, level 2 cache, level 1 cache, right? So what is happening here? Instead of the frequent instructions which are used to compute the program, execute the program, that can be stored into the CPU itself. Okay, because otherwise CPU will go and fetch the instruction from the memory cycle. Instead of that, it will do the transactions and which are oftenly used. That can be stored into the CPU itself. Because with that, we can reduce the processing time. So that way, large scale, if you want to do computations, the cloud use the edge computing, because the local servers will do the computations, and it will enable the global servers. It will help the global servers fastly to compute the processes. So for that, we can use the edge computing technique. It is an abstract way of explanation of edge computing. Clear? Okay. Okay. Good. So yeah. So next, I discussed about MaaS core principles and layers. Then we go with the MaaS business model. So you can see here, platform acts as a broker, takes a cut from each transaction. Example, Uber. Commission-based model. The business model here is commission-based. The best example is Ola, Uber, Rapido. Here, both the parties, like the driver who is going to drop you into your location, he have his own car, but he have to get amount from your payment. So here the model means the application, Uber application will get the amount from the both the parties, like you user and also the driver. Okay, he will pay to the driver, and some percentage he can get, and that is the revenue for the application. Hope you understand. This is what commission-based business model. And user pays a monthly fee for a bundle of services. That is what Metro card. So using the Metro card, you may do shopping in the metro stations. You may use the journey ticket for the same card, and you may get some drinks and over there, and you may do some shopping. What see the same card you can utilize for different things, but you have to pay every monthly you have to pay. So pay and use. If your bill is more, automatically your credit card details are with them. They will charge you. Then it is in the cloud. Actually, there is a billing model there. First, they may ask you to attract you. They can say you give you 1 rupee to get a services. They introduce the services like Geo. Once we got habitual to the services, they charge you like anything. If you want, you can. The best example is Netflix. Okay, that is what subscription model. You got my idea? That is what subscription model. Then coming to the another one is apps supported by ads are selling aggregated anonymized data. So it is the revenue model where the mass based model where advertisement and data monetization. So here from the ads publicity, even in the metro also you may see a lot of ads going on. So these are all the revenue for that public transport system. And providing mass solutions to corporations for employee mobility. So business to business model. So these corporates are interconnected, and transport system people will attach it with the corporate people, and corporate people will attach it with the vice versa. They are going to use the services, and they are going to generate the revenue. This is the different ways of business models available in the mass. So that is what it is, a pay as you go and subscription based monthly, corporate mass, then public private partnerships and data monetization. These are all the different business models in the mass. Then who are the stakeholders in the mass? So transport operators and government agencies, communication technology providers and users. These are the major stakeholders in implementation of the mass. To make you understand the mass, I divided and I am going to share you the stakeholders in the mass. Then what are the global case studies? If you can observe, yes, already the mass got implemented in different countries, and the repeated applications are Vim. It is in Finland. You go and search for Vim application model. It is a subscription-based integrated mobility widely used in Finland. Everybody using only one Vim model because the policy is like that. And move it in Israel, real-time multimodal planner. So using the Move It application, people will plan their journey and they do the journey. And Uber London Transport API based integration. So Uber and London Transport is a public transport, and these two applications integrated through API, and that application will be used by the users. So these are the global case studies. If you can go and you can see, you can observe, you will get a lot of literature on these applications. So MaaS in the Indian context. So these are the opportunities and challenges. When it comes to India, you can see the diagram. See what is the density. So for them, the countries like India, where public is more, so the opportunities are massive because mobile first population. We are all utilizing mobile like anything. So that is the major opportunity to developers who are developing the MaaS, and high demand for affordable, efficient mobility. If it is affordable, see as I told you, na, if it is affordable, people will come. That leads to traffic. So affordable and efficient mobility is another one. If you can able to develop a application where people can afford easily, and if they would get efficient mobility, the demand is like anything in India. And government push because Modi, Narendra Modi ji, our Prime Minister, initiated a lot of missions in which smart cities mission, digital India, make in India, and the electric vehicles. I think the down the line, coming 4 to 5 years, all electric cars will come to the normal car rate, petrol car rate. So that is the initiations government of India is taking that will give a lot of opportunity to the developers to implement the MaaS and vibrant startup ecosystems. So everybody is coming forward to develop this. Even Uber also a startup idea. And I think you know the story of Ola. And one IIT student, when he left from the IIT to the airport, he thought he may drop in middle in the road. Then he decided, why don't we have an application to get a mobility? So from his mind, that that idea is coming forward, and that can be you know uh, developed like anything now. How the usage of that Uber. So like that, how we have opportunities and also we have challenges. That is what number one is regularity hurdles, integrating auto rickshaws, information transfer. To implementing the things, regularity efforts are there. These hurdles we have to face. So integrating from autos to rickshaws and informal transport also a, a major challenge. And data standardization, lack of unified data formats, example for buses. I told you in the first slide, I asked you, what is the solution? What is the solution when women are more in the bus? So for that, if we can have a card like with is integrated with the Aadhaar card and driverless transport system, where you may keep a reader at the entrance of the bus, automatically, if you can keep the card, you can, if you have a seat, you are allowed into the bus. Otherwise, you have to wait for the next bus. Then automatically, the occupancy will be managed, and it may lead to safe and smooth and efficient journey. You can give this as a problem statement to your students. They may work and they can develop this as a case study. Okay. So, like that, every day we are going to face a lot of problems here and there in our nearest places, but we are ignoring that. You have to work for society. Society is facing a lot of problems. So, you develop your research, do your research, passionate your research to solve the societal needs. Then only research will have importance. Okay. So, data standardization is another one, another challenge, and digital and financial inclusion, ensuring access for all. So you have to have a sophisticated platform. It will ensure access for everybody. Okay, and infrastructure. Majorly, we are facing a problem with reliable internet and digital payment rails. So these are all the challenges in the Indian context. But if you go and see as global situations, global areas, there you no need to think about all these aspects. But this slide is for only for Indian context. Uh, This is my study. I given some inference to you. Kochi Open Mobility Network started using the beacon protocol based for MaaS. It is now in the usage, but it is in like literature only. It is going to be implemented full fledgedly soon. Now people have started using Open Mobility Network, Oman, and Yulu bikes, micro mobility and IoT integration, and Ola, Hyderabad Metro, unified ticketing. I think these are all the Indian case studies where MaaS already implementation gets started. So when it comes to policy and regulatory frameworks, EU MaaS directive is a framework. You go and search in internet, you will get a lot of documentation for policies, what they taken for implementation of MaaS directives in Europe. And also National Urban Mobility Policy in India, NUMP is also there. Please go through it. You can see the policy document. You will get how to implement, what are the policies involved, how it is useful to implement the MaaS, and need for open data and interoperability policies. So there is a damn need for open data and interoperability policies. See, here we have a lot of restrictions. Our data cannot be shared to the next person because we have a lot of security aspects, security issues, data privacy and preserving issues, and security concern, integrity issues. There are many issues in forensic and cyber laws. So the how to focus on these laws and regulatory frameworks, regulatory bodies. You study on it and you develop an application. It perfectly fit to the Indian policy system. Then only it makes sense. Then finally, this is the roadmap, the road ahead for challenges and future directions. Persisting challenges is governance and regulation. Who owns the customer and data privacy? People are people are not owning the customer. If you can own customer is your god, and if you can provide data privacy, so the government will think and they have to come up with a policy where it's supposed to the public. Then this type of ecosystem we may build in all Indian cities. Then the sustainable business models, profitability is elusive. Okay, we have to build a model where it can be sustainable. Okay, and it never fail. It have to get profits. Okay, that is elusive, and achieving critical mass of users and providers. Then only we can get the mass users and also providers. And the future directions are AI powered mass, hyper personalization, autonomous vehicle integration. So slowly in Dubai, they started air vehicles, autonomous vehicles, and we are using drones. Now drones is used in India and in military and in other defense systems already started using drone technology. DRDO is focusing more on the drone technologies, and autonomous vehicle systems is the era in coming future. So AI powered mass is our challenge. So that we have to focus, and AI techniques and collaborated AI and federated AI is plays a vital role, and generic AI also will coming in near future. By 2050, you may see uh, generic AI and artificial intelligence. So means what? Everywhere AI, everything AI. See, human intelligence is replaced with generic intelligence. So definitely we'll have a society where GI plays a vital role. At that time, everything will be monitored properly, and human beings will lead their life smoothly without carbon emissions, without uh, uh, you know abnormal condition of weathers. They can live their life smoothly. So these are all challenges because of in our inefficiency. We are not managing things properly, and technology is growing, but parallelly the policies are not implemented. That is why our the planet is affected with warm global warming, and it may lead to abnormal rains and cloud burst and flooding. So these are all abnormals. In time being, the down the line of the time, you may get a lot of natural calamities may happen. So to stop it, you have to think about sustainable technologies that will make our planet more sustainable in years together. Okay, so sustainability first MaaS, prioritizing green routes and EV options. So this is a very very focusing and alarming thing. We have to think, we have to implement sustainability first MaaS. Okay, sustainability first MaaS. Okay, with respect to profit, but you have to focus much prioritized for the word sustainability first. Okay, and MaaS 2.0, integration delivery logistics and other urban services. Now we are at if you think we are at MaaS, now assume pre-assuming that MaaS 2.0 may provide integrating delivery logistics and other urban services as well. Okay, so these are our future directions for MaaS. So what are the challenges in implementing the MaaS? Data ownership and sharing. Everybody have their own ownership. They cannot share the data. Sharing is very difficult. Okay, because a lot of protocol formats we have to integrate, and building applications is a challenge. That is why is the first challenge. Lack of standardization. Every IoT device having their own standards, so there is no proper standardization. Unified model is not there. So we have to focus on making all industries will follow IoT based standardization. If you can implement one framework that can be automatically applicable for the other industry, if you can achieve that, so this lack of standardization will be eradicated. Then institutional soils, every institution having their own regulation rules. So we have to focus on those institution soils as well. And public awareness and adoption. See, even though we have a technology, but public is not intelligent, they may not having the idea how to use the platforms. It is no use. That is why we have to give a lot of best practices in the form of services to the public. If they will adopt, if they would use the services of the application, they can habitual to that. Then they involved. Then automatically the usage of MaaS get increased. So they have to adapt the technology. So for that, at first when developing of mobiles, people think that whether this mobile will reach to the normal layman, but now everybody using the mobile technology. The down the line 10, 15 years back, so there is no there is no proper technology, high end technology. Now we are smartphones are coming, came, and we are all using the smartphones like anything. Now all phones are using connected with IoT, and we are operating all your devices in your home automation, Alexa. Okay, lot of technologies are evolving. So now we can think about Alexa without internet. Okay, Alexa with internet, without internet. Why don't we have Alexa without internet? So that aspects you have to think. Okay, so these are all the challenges for implementing the MaaS. And future trends. The future trends are AI-driven demand prediction. Okay, and I don't need to tell much about demand prediction. Okay, AI-based, AI-driven demand predictions. And AI means AI is the part of in technology. AI will help in the MaaS. AI is involved in the MaaS. Then 5G enabled connected mobility. So because of 5G, I think Bharat Sanchar Nigam, BSNL, using our own technology to build the 5G. If it comes, the rates coming down, and every individual may get a subscription with very less. Hopefully, we may get very soon. And blockchain for secure transactions. Nowadays, security is a vital role. So for revenue records, we may use blockchain. We may build a decentralization oriented files. So if you made a change at one location, the change should reflect in the entire block where it is, integrated. So the blockchain based secure transactions are plays a vital role. and electric and autonomous vehicle integration. Everywhere, people may use electric and autonomous vehicle integrations as our future trend. Okay, so these are all not limited. We have a lot of, but I focused 4 to 5 points here. And sustainability and mass reduction in congestion and emissions. So we have to think about sustainability to reduce the congestion and emissions as well. Carbon emissions will lead to a lot of health issues for every individual. Okay, so please think about that aspect. Promoting public transport and shared mobility. So already started. We don't need to promote because from Gachibowli to airport, people are not going with their own one vehicle. They are going in shared mode because instead of waiting in the traffic, they have to go with shared mode. So that itself, we are promoting public transport and shared mobility, alignment with the SDGs. So any technology we would develop that should be aligned with sustainability development goals. Okay. So these are the sustainability aspects we have to focus while implementing MaaS and while using the MaaS as well. And interactive discussion activity. So if you really understand my lecture, we have to plan and we have to design a MaaS model for your city. I don't know from which city you may belong, but you have to think about. Please give just 2 to 3 minutes thought for your mind. So, what model can I suggest to the society where I am living? So, what models will you integrate, and what business model first best for you? So, after this session, if you have time, I am expecting you to please share your ideas in the chat box. Even I too know your thought process. Then from all this thought process, we may come up with a solution that may really useful to the society. Okay. So why I am telling that, because in our first year we may ask our students to go and visit the nearest villages. We have a subject. Okay, so our students will go and visit, and they will come up with the problems. They will Community engagement is the subject name. They will go and engage with the community, and they identify the problems near to the villages, and they demonstrate and they prepare a book and submit the problem, and also what type of solutions they may uh, trigger to solve the problem. But in the second year level, after learning the technology, they may implement the same problem in their BTech final year project. We don't know. So, like that, some students really they are good at problems. They may identify the problem, they develop the solution. Similar passion, I am asking you here in our entire 1.5 hour session. So you understand about MaaS, and you please plan your idea, your thought. What is the solution, best model to integrate, and what is the business model best fit for our city? Okay, so that is what I'm expecting from you. Then finally, the key takeaways from my session is MaaS. It is an integration of innovation and inclusivity. We have to focus on triple I: innovation, integration, and inclusivity. India has strong digital foundations for MaaS. Now we are growing. We have a lot of initiations, lot of support from government of India. Even Telangana government also supporting. If you have a real problem, you go and demonstrate into the venues. They will consider. There may be a lot of angel investors coming forward. If you go and demonstrate your problem statement, your idea or your proof of concept in these startups like Startup Hub or T Hub, you go. There are angel investors. They come forward to invest on your problem statement if it is really suits to their business. And collaboration is the key. Finally, for everything, collaboration is the key. Here, MaaS is a collaboration of public, private, and policy. With only private, we cannot do anything. With only public, we cannot do anything. With only policies, we cannot do anything. So, public interaction, private interaction, and policies of the government all together, combinedly, collaborationally, come up with a MaaS solution. Okay. So, these are my key takeaways. Finally, the conclusion towards a smarter urban future, MaaS is a paradigm shift from owing mobility to consuming it as a service. Okay, this is what a model. This is the one approach where we are going to get a service for our payment. With that, we will get a lot of benefits. Its core value is seamlessness, efficiency, and user centricity. And Internet of Vehicle is a critical enabler providing the real-time data for the system to function optimally. Because we are working on realistic data that will solve our problems. And success requires a collaborative ecosystem like public, private, and academia. Because the researchers we should involve people like you should come up with a solution and that can be implemented in industry. For India, the potential is enormous, but it must be approached with context-specific solutions. We have a lot of potential. We have to focus on, context-specific solutions. So, what is that? That's what I told you. In one village, the problem is different. In another village, the problem is different. Okay, you have to come up with a solution based on their context. Okay, so so that is about my conclusion about the session. So if you have any questions,
Are there any questions from anybody's side? Okay, I will take that as a no. Thank you so much, sir, for joining us today and enlightening everybody with this session. I thank you so much for all of your insights. And I would like to conclude the session by asking everybody to turn their videos on for a group picture, please.
yeah, I'm sorry I got disconnected. Uh, Further, if you have any question, you please.
Sure, sir. We'll reach out to you. And could everybody please turn on your videos?
Sir, a small question, sir.
Yeah, please.
Uh, what would be what would we make you personally uses a MaaS platform regularly, sir?
What would be?
What would make you personally use a MaaS platform regularly, sir? Personally
Means
use a MaaS platform regularly.
see, there are a lot of difficulties. Like when you're traveling from your home to any place in the city, so we are facing a lot of difficulties with respect to transport, with respect to payment, with respect to services. So for that, only one solution is MaaS. Because
Sir, is there any barriers to implementing this MaaS, sir, in our cities?
barriers, that's what policies are barriers. Because policies are not allowing us to implement our own applications. You thought that I want to implement something, you didn't have a freedom to utilize your application. You have to follow the standards.
Okay, sir. Then we have
That's what
actually
in my
AI.
slide down I mentioned PPP, public private partnership model. We have to work
Yes,
on it. Yeah,
yes, sir. Recently started AP government, sir, this concept.
exactly. API calls also very, very important
Yes,
because
sir.
API calls at application level.
Sir. Sir, we have various emerging technologies right now, no, sir. How do we improve this MaaS platform by using these all concepts?
Latest AI algorithms we can use to analyze the data sets because we are capturing a lot of sensors data and we can store in the cloud, and while implementation we can develop a lot of algorithms and we may use the rule based engines and we may generate the reports finally, and that reports will be deployed into the user interface. These are 4 layers I discussed. Na? Layer 1, layer 2, layer 3, layer 4. The last
Yes.
layer is for user layer, and we have a transport layer, and we have a session layer, service API based layer. Okay. By using all these layers, we have to develop an application, and that should be very sophisticated. And in every layer, the flavor is sustainability. Without that, if you can implement, no use.
Okay. Thank you, sir. Thank you.
Yeah.
Thanks for that answer, sir.
Thank you.
Sir, I have a question.
Yeah.
What is what is the case study of Hyderabad Metro when they had tie-up with Ola? Like, is this model worked in Hyderabad, or currently, what are the outcomes of it, sir? Whether it is successful here or not?
That users should say, because still we are facing a lot of issues with Ola and Uber, because you may select one application, you may select one route, but that is not updated into the app. They may question us, sir, I selected this route, this amount I mentioned, but while leaving that journey, stopping the journey, the rate may be varies. That is what poor pricing is one aspect, and measuring of distance is missing because of AI is not properly executing, and interface is also having problem. It may showing something to us and something else to the driver. So these are all the issues still we are facing. See, we have gaps. The real industry, if they want a sophisticated application, they can build. Definitely, you may get an option to utilize the services. That is why Rapido plays a vital role right now. Rapido come up with bike. Now they are moving up to cars as well. Okay, so still even Rapido also having a lot of problems. So MaaS will have a lot of scope to improvement.
Sir, according to you, which metro in India is most successful, sir? What is the model adopted by them? Like, are they able to reach last mile connectivity? Is it successful in India in any of the metros in India?
That I didn't say it is successful. Some cities it is successful. Some cities it is not successful because the density is high. We are not getting the services from that metro. And some cities where the density is low, the services are excellent because maintenance issues are there.
Okay, sir. Thank you.
Yeah, thank you. That is why recently the metro people is requesting government to take over. I think some areas they may hand over it to Telangana government. I think it's something going on. That's why the policy is also very important when implementing the MaaS. Because ultimately everybody is trying for bucks only. Revenue is the ultimate, target. That is why we have to focus on in all these aspects.
Thank you, sir, and thank you everybody for joining. We will be starting our next session at 7:30 p.m.
Yeah. Thank you, Vanilla, for patience listening. If you have any questions, please reach me through my mail ID. The coordinators may share my mail ID to you. If you have any question related to my topic, you can pose your questions, and anything related to your research also you can pose me. That may be helpful to others. If time permits, you please think about that case study I hand out. Okay. Thank you one and all. Thank you very much for your patience listening. Thank you.
Yes, sir. Thank you very much.
Yeah, madam, I am leaving now. Hello.
Yes, sir. Yes.
Yeah, thank you.
Thank you, sir.
Good evening, everyone. I request everyone, please complete the poll session. poll is there, then please all of you go through that poll.
This
Hello, good evening. I hope you can hear me now.
Yes, sir.
Okay, good evening. Thanks for the kind introduction. Good evening, everyone. My name is Giriraj. I'm based at Singapore. Vehicle to vehicle to everything and associated communication. So I'm glad I can share some of the key aspects of this from an industry perspective. I understand most of you are from the academic background, yet even though we work more on the research and communication activities, I will also try to put it an application flavor to it so as you can have a better perspective of appreciation over this topic. During the course of this session, should you have any questions or queries, feel free to put your questions in the chat box so as either we can take it immediately or sometime after the session also. So a little bit about myself. So myself, I have been in the industry of intelligent transportation systems and homeland security for the past 25 years, and I'm working in the Asia Pacific region, primarily involved as a smart cities consultant and also working as a policy maker in terms of implementing intelligent transportation solutions and also homeland security methodologies in various Asia Pacific countries, including India. So the key thing that even though all three these years, if I have been working on, one of the key thing I found out is working about technology is a different thing, but end up everything boils down about people. So later V2X. So basically, if we look at the way how the world moves today, right, the key thing that we are seeing is there is a big buzz going around on driverless vehicles, autonomous movements, navigating from one place to another in various means apart from the traditional means of transportation or commuting. Today, when we talk about smart cities, intelligent transportation systems becomes an indispensable part of the entire eco system itself. So again, the key aspect of smart cities where I originate from in terms of design or implementation, we always talk about traffic. We also talk about commuting. We also talk about the what we call as the livability of the people in the individual cities. But the challenge is not just people, but also about the technologies that are either not being adaptable or being adaptable but not able to be implemented in the bigger scale. So even if you talk about this topic of vehicle to everything, I think it is not really, I would say, a futuristic topic. neither it is a topic that has been already well adopted, because for vehicle to everything, it does needs not just technology, a strong framework apart from the implementation methodology, apart from the technology to come into existence. In the coming slides, I would also share with you some of the key things. Even if this technology is available today, if you look at the countries that have adopted it and implemented it successful, is a handful of countries only, and even little is more of countries that have actually come out with people friendly policies, governance mechanism, and frameworks. So no matter all these limitations, or what I would say practical difficulties, today this is an emerging topic that is being taken into any mobility conference as a key debate. So it is not just about vehicles talking to vehicles, because that was the past. Today, we talk about intelligence of having a situational awareness of what is happening around being, and things has been proactively communicated to the respective stakeholder. So let us go individually to each and every one of this particular topic. When they say V2X, they actually refer to V2 everything or vehicle to everything. But individually, it can also differentiate it as vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian or people, and also they talk about vehicle to network, or sometimes they call as V2G, which is vehicle to the network. So the vehicle, it could be any type of vehicle, it's an automated vehicle, or even it could be still a driver vehicle, manned vehicle, still has to communicate with these four or three other stakeholders for various reasons. Like for example, today you might have seen as a daily scene in many of the busy cities and traffic junctions, when an ambulance is passing by, you might have seen it might have stuck in a traffic, or the traffic signal may be still in the red, or maybe some heavy vehicles can be going across perpendicular to the lane or whatsoever. These are all because everything is running or moving independently. Whereas the main purpose of V2X is actually to have an cohesive approach in the movement or in the mobility of vehicles in any city, or not just cities, it could be even in the expressways, or what we call as the highways, or other things also. So why it is really important, why we need to adapt, or what is the need to have a V2X implementation, or why it is so vital in today's modern world? Because as I mentioned today, there are four topics people always talk about smart cities. The first thing is the livability of the people. Second thing is about traffic. The third thing is about public space. And the fourth thing is about the digital services. So as you see, you can name any big city in a developed country, or an emerging market, or even a growing country, it's a third world country. Traffic or transportation or traffic congestion, or all these parameters, this makes the biggest issue. People tend to spend hours on the road or commuting to work just because of this reason. So the key thing is, first is about the livelihood, as I mentioned. So we want to talk about prevent collisions or prevent accidents, or to have a safe passage for everyone who is commuting or traveling in the roads, and also to improve the traffic flow so as vehicles won't stuck in between, there is no other things. And end of the day is also about improving the overall efficiency in any particular part of the city, or in the entire state or country itself. So when we talk about communication, right, these are all vehicles or the technologies where either one of them doesn't even know each other in before, and there is no configuration or anything, there is no wiring, there is no send receive methodologies. So the key thing, the only option that we have for this V2X communication is actually wireless. So again, there has different technologies has been attempted in the past with radio frequency in different bands, spectrums, with the different type of communication techniques. And as of now, even though what you can see over here, three, it is actually only two different type of communication. One is actually 802.11p and BD, which is a direct short range communication between two independent vehicles, or what we call as a peer-to-peer communication. Within a certain range, they can exchange data, they can communicate between. And that is important because in a remote location or in maybe a far away places where there is no coverage of a established grid or a network bandwidth or network framework, then you really need a transceiver type of communication where you will have a peer-to-peer connection established and data communicated over it. Whereas in developed markets, we see an increased convergence where the communication is actually done through an established network framework, but by an operated service provider. Either it could be 5G or even CV2X in a higher level also, and to assuring every level of communication, every level of data transmission is being covered across every nook and corner of the city, despite it is an high electric zone or high industrial zone or whatsoever. So since we talk about communication, right, if I may ask, okay, before I ask this question, I would also say that both of this type of communication methodology that widely used today is actually operates in the 5.9 gigahertz bandwidth, which is because IEC has actually assigned this very much for the intelligent transportation system bands, so primarily used for ITS applications. So when we talk about this communication between vehicles, communication between vehicle and infrastructure can be a bridge, can be a building, can be a traffic signal, whatsoever. And we also talk about communication between a vehicle and person. In the previous slide I show you. And we also talk about communication between vehicle and the network. So what do you think must be the most essential part of this communication? You can just type there is no right or wrong answer. Please feel free to type your answers in the chat box. Let's make it a bit interactive. So out of this type of communications, right, V2N, V2I, V2V, and vehicle to pedestrian. So what is the key factor in this communication which is very vital or important that you think? Internet, yeah, connectivity is a very important factor. Thanks, Mr. Manohar. Any other? So if you look into the application itself, right, we are talking about the purpose of V2X is to prevent collisions, improve traffic flow, enhance efficiency. So to make all these things achieved effectively, what is the one factor that you think is very important? Yes, internet framework or network should be there, connectivity. Sustainability, yes, reliability and sustainability is very important. You cannot have a broken connection or a call out things. Efficiency, that's right. Yes, yes. Thanks, Swati. Anything else? Any guesses? So let me give you a clue. So does all this communication happening in real time, or it can be happen in a later time also, or it can happen after a while? People friendly, yes. So one very important aspect of this communication, of course, efficiency, sustainability, and people friendly, all very important. And another important thing, or the most important thing usually we consider in such communications, is speed. Imagine if the speed is not there for such communication. Say, for example, a vehicle is coming near another vehicle, a vehicle is about to hit a traffic light, a vehicle is about to hit a transformer on the roadside. So there should be some communication extended or alerted immediately, right? So today, one of the main reasons to implement V2X, even though we can talk about efficiency, effectiveness, and all, one of the key reasons is to avoid accidents or avoid unpleasant incidents on the road, which is not only impacting the vehicles involved or the infrastructure involved, but also it produces a cascading effect of affecting everything beyond. So you can see that, right? Normally, if there is a small accident on the road, you can see kilometers of traffic jam happening. So speed is a very important factor, and the speed is not only the connectivity speed, but also it is about the speed of data communication or data handshaking between the two sides. So you must have a sustained network ability, reliable connectivity, and the data must be communicated, or the information has to be exchanged in a very fast manner. So this particular picture actually explain you the type of different communication. And as I mentioned, why speed is important is to prevent incidents. So because we are working on a real-time basis. So when we talk about speed, we always talk about the opposite of speed. So I think most of you might have studied on the network part also. So what is the biggest challenge when we talk about network communication from one point to another? What should be reduced? Yeah, slow networks. So latency is the biggest challenge, right? So today the challenge in noise, yes, perfect. Yeah, noise is another factor. Latency is another factor. So these all contribute, because you are not talking about a very conducive, clean environment where the data is transmitted across or exchanged in between in a very secluded way. It is a very it's an area where you can talk about lot of radio frequency interference, high electrical radiance, and other factors, also environmental factors that could impact. So that is the reason implementing V2X has a lot of its own set of challenges also. However, I think we saw these three factors, right? The first one, it is very important to have a reliable network. Either it would be a peer-to-peer communication, or we can have a communication between two parties through an established grid. The challenge is we must have a less latency enabled data communication, and the data exchange or acknowledgement or the handshaking has to be much faster. So where are we today? Since we are talking about V2X today, where are we actually in implementing or adopting V2X in the global situation? So as things has rolled out in Europe and US in the initial stages, we have seen different technologies has been attempted. There were some good results. There are some failures in the past also. So there is still active pilots ongoing, but not in the general what we call as congestion areas or general areas where the vulnerability and volatility is very high. Instead, USA has taken a very careful step in terms of implementing this or attempting it in certain states where active pilots are ongoing, where the infrastructure and everything is being supported. While US is taking a very advanced, faster approach, we also see Europe is following up in a more cautious and structured manner. As you know, European Union or European countries, they take in a very strong people-oriented approach, and also they also talk about they don't want to have individual standards like, okay, brand A of a vehicle introduce one particular proprietary protocol or a communication methodology which other brands or other technologies won't adapt. So EU is adapting a methodology or some kind of IEC and international standards. So as most of the V2X communication across different stakeholders follow a standard, international standard. So as it also not only it increases the speed of communication, it also avoids any duplication of effort and any wrong heading in this direction. However, contrast to it, you can see at China, in certain cities, it has been widely practiced or it has been at least attempted. In Korea is the same also, where the V2V is getting more prominence, even though, but in China, even we see V2I, the infrastructures are almost having their own. Today, we see the edge computing devices, IoTs are getting more and more higher computing power with good connectivity. And that is the reason today the front end devices has been placed, the IoTs has been placed inside this infrastructure, whether it is a street lamp or it is a bridge or traffic light, or it may be just a milestone on the sides of the road or a signage. Everything is getting more and more intelligent than before, and they are start communicating and they are able to not only just receiving data, they are also able to make decisions and also able to manage the situation around the vicinity. Thanks for your contribution. So as we spoke, right, so we just talk about these things. So what are the key aspects that you need to look at in terms of understanding and implementing a V2X solution? So the primary thing, as I mentioned, is about latency. Even a millisecond response, it could make a big difference. So we need as fast as possible to communicate reliably with the other side, because it could, every millisecond matters when vehicles are moving at a several kilometer or miles per hour speed. So it depends on where the location is also. And the next one is also, is we talk about, we cannot have a very established network implemented infrastructure in every part of the world or every part of the country, especially countries like us in India. It's very huge place, and we need to cover several millions of thousands of miles in the whole country. So we cannot just say, no, we are just going for one approach. We are going for an established grid approach, or we are going only for a peer-to-peer V2V or V2I infrastructure. So if you want to start something and move forward, and you have to move fast forward, I think one of the chosen option is hybrid ecosystem, where this system must be chosen in adoption. Maybe in a city area, it could be okay to implement a V2V, V2I platform type of communication. And in beg my pardon. In a city area, we will go for an established network communication, and in the outskirts, in the highways, expressways, where we have remote locations, where there we will choose to go for a vehicle-to-vehicle communication. And again, as I mentioned, today, not many countries having their own standards of this communication between the V2X devices or equipment. So traditionally most of them still following the standards that has been introduced and implemented in the European and US market. So we talk about speed, we talk about standard, and we also talk about implementation, right? One of the another important aspect is when we open the door, we also open the door not just for the visitors, right? We also open the door for some unwanted guests. So security becomes a key aspect also, because if this can be a channel or tunnel for entrance into a certain infrastructure or certain facility, that would be a difficulty. Anybody can do anything if they are capable of. So you need to validate the message or the communication originate from the right source, and it is a reliable data, it's the right information. So certificate exchange tokens, these are all also coming into play. That's what we generalize it as security. So again, in the past, we always say, even when we reverse our car, we hear a ring, music tone saying, hey, I'm about to hit the wall, or there is something that I can sense. So sometimes there are sensors always placed in which we may not even notice. But majority of the time, these are sensors which actually log the information, but doesn't effectively do any big activity. Sometimes vehicle manufacturers does use this information for the servicing analytics. So how much vehicle has run, what is the average speed, which are the moments the vehicle has not responded fast and all. So today V2X actually becomes a complementary to the existing sensors in the vehicle. So the sensor is more of the sensing part, but to do some intelligence with the data that is being derived from the sensor, that is where V2X is coming in. Okay, say for example, when in the previous traffic light, the bus is crossing, then the person or the people standing in the next bus stop, they already receiving a message. Okay, bus number 28 is arriving in 1 and 2 minutes. So this is something making them important. And maybe for the vehicles who cannot see behind when we drive, there is an ambulance coming in the road. So they can make, we not just after hearing the ambulance siren, they can be prepared before. And sometimes you can avoid the roadblocks also, roadblocks, potholes, or some unpleasant situations in the parkings. There is so many other type of applications in the smart cities domain that you can assume. But having said that, all right, one of the key application, as we say, is still we talk about people and traffic again and again. So how this technology enable it? So to me, as a smart city consultant, I always put people first. So I tend to see what this can actually help for people. So if I can reduce the noise of the vehicles, if I can reduce the pollution in a particular vicinity, if I can reduce the traffic, so that should be the way how we usually look at these things, right? So implementing a technology must be something that it can produce and it can effective. So V2X is effectively making the systems or the infrastructure in the city or in the entire ecosystem to talk to each other, and not only talking to each other, to inform and alert in an earlier stage, so as the respective infrastructure or the other vehicles can automatically adapt. So not necessarily to wait for our acknowledgement or confirmation. Sometimes the systems can actually respond by itself also for certain things. So this can be either automated or semi-automated or just a pure notification only. So this is what we call as a non-line of sight awareness and non-line of sight activity, where apart from what you are driving or the vehicle is going by itself, there is a lot of things that can be improved operationally in the whole environment just using this methodology. So before I touch the key benefits, is there any questions so far? Are we going good? Please feel free to just type your questions, anything inside the chat box. Thank you. So again, today we might have seen that there are only a handful of countries or developed markets which has adopted the V2X, but that doesn't mean that we are not going in that direction, because things are going very fast, things are changing very fast. How many of us would have imagined about 15 years or 10 years before we would have a toll-free fast tag system? No cash collection in tolls type of thing would be implemented in such a scale in India. So these are similar things that we do not predict today, that it will take a lot of effort, time and investment to move forward. But having said that, certainly there are practical issues, certainly there are difficulties. So some of the thing, because today the vehicle manufacturers are the one who is counting more on this particular technology, because it is also a compliance in certain markets where certain capability, like you go very near to a vehicle, it must have an auto brake application. So that is something you can see in some of these recent vehicles also. So imagine that if your vehicles can communicate and talk to the other vehicles and the infrastructures, and also a person wearing what we call the smartwatch or with a mobile phone in his pocket, he's just crossing the traffic light or in the time when there is a red light. So he may receive an alert in his smartwatch or his mobile phone, a small tone, beep tone, just warning him, hey, you are doing something wrong. Like something like at least make him to wake up, not to do something wrong. So we see a lot such applications, very small applications, but it makes a big difference. As long as you see life-saving applications, sometimes that also helps. So safety is one of the key benefit that we assume. And, city administrations mainly count on this. Governments look into it. Vehicle manufacturers, despite having a lot of new safety techniques and methodologies introduced, we always have the numbers of the fatalities on a per year basis in emerging markets is going in a same number or not less anymore. Because when we see better roads, we tend to drive faster, but not more careful. And efficiency, increasing the overall efficiency of traffic, which will help to reduce congestions and also emissions to some extent. And the most key thing that we receive from the transportation authorities, Ministry of Transport, local administrations is the data that they receive for predictive management, because they are able to get the patterns, because each and every vehicle today, even with the FASTag, you can see it has been already categorized. If you want to do statistics or analytics of, okay, in this particular toll at the outskirts of Ongole, how many long truck and how many heavy vehicle of this particular size has been in the past 1 month. So that would justify why the road actually has been damaged compared to any other road. So the next time when they issue a contract for the road reconstruction, maybe they would be more careful, or they can put a better specification for a better deployment of this road. So these are the way how this information or this technology would really help to improve the overall operations and activities. So smart city, we don't talk about just technology, but end of the day, when implementing this technology, enabling this technology into the actual infrastructure or actual day-to-day, we want to see what is the effectiveness in the outcome of livability in the lives of the residents. So if people were in the past having a very bad impression or very bad experience commuting to work on a daily basis by car with congestion and with a lot of these issues, ambulance or heavy vehicles crossing in, has it been made better after implementing this? So we capture this data for over a period of time, we analyze it. So end of the day, this is not just a one-off process, whereas V2X actually helps to improve the process continuously over the period of time. So the more the stakeholders, like a school zone is another example. You can talk about places of worship. We can talk about some hospital zones and all. So this is what we see, that different countries can come out with different application scenarios where the value of implementation or the outcome gain can be more increased depending on the right deployment methodology. So as I mentioned about smart cities, right? ITS is intelligent transportation systems, where usually we take these 5 factors as one of our key KPIs. You can say these are our KPIs, because with the increased number of autonomous vehicles in fewer of the cities, or maybe not autonomous vehicles also is fine, what really we value add to it by implementing this. So it's not just V2X, it could be even any other methodologies. So in the past, manufacturers come with their own techniques, own innovation, and own creativity to do things. Today, the good news is a lot of governments has formed agencies, and there is a private sector also. We call as a ITS society or ITSS. They, in every country, in India we have ITDP. They are also playing a very important role. So they come out with a lot of white papers, case studies and all, and saying that, okay, these are the things that can be adapted, these are the things that can really change these difficulties and all those things. So that is helping the vehicle manufacturers and also the policy makers to regulate and put things into place. So we can do it in a very early stage. So we see it in both ways. The countries, like I show you the US case before, where they were before the first ones to try certain things, so they did some mistakes, but other countries learned from that mistakes. So if we have not adopted it yet, then we still have a chance to avoid the mistakes of making something wrong. So the next one is, we also don't want to see V2X or any other ITS technology per se to be a standalone thing. We want these things to be more integrated into one ecosystem and in the city administration. So one of the framework usually we suggest is, okay, ITS must be a part of the smart cities solution. So as anybody try to do this, or anybody try to introduce this, we can use this approach, but it has to be so that it has to have some standard of integration ability with the smart cities. So the next one is, again, we talk about the standards, right? So there are global standards, and what we do is we take the best practices, and not every standard can be applicable in every market or every location. So we try to take those standards, and we also try to prioritize what are the must to do and what are the good to have, and what are the things that can be more on personal safety, that can be an added enabler to the safety also. And the next one that we spoke again is about security, because hacking or whatever we talk about, any other type of tunneling and cyber vandalism and all is increasing in different manner, because we have been talking about several billions. I'm not sure the exact number, you can Google it. We are talking about few billions of IoT devices in the connected to internet today. So how we are going to have a secure communication among them, and added to that, we are also adding new devices, new technologies in it. So then the next one is, we also talk about data privacy. We are not only talk about security, we also talk about data privacy, because if I know John is going to travel from point A to point B, and he knows that his system is being all the while connected to a public internet or maybe to some system, at least the manufacturer or some authority may know where he is traveling. Today we might have seen maybe personal data might not have that much of high value or that much of high sensitive, but it is an increasing thing. We have a strong data protection act in India also, even though it is, but we still use it for more personal data protection aspect only. Like if you might have seen recently some act amendments has been made. Even our Aadhaar numbers could not be shared fully to anyone, so you can demand to share only a certain part of the number for verification also. So these are all the concerns that people are looking at it, and it can be challenged in the court also. So there need to be a legal regulatory framework to ensure the data is being protected, personal data, and also there are cyber security, data security measures in place. Apart from this, there are broader implications also. When we talk about it, there are positive implications also, like we can say the livability of the city, as we mentioned. So especially we see the predictive analysis helps a lot. We have seen cities has changed a lot. People's mental state of mind has improved a lot. To surveys happened over a period of 5 years time, 3 years time. There were positive impact when people some small measures have made big differences. Like there's one good example I would share in Indian cities also. Parents doesn't want heavy vehicles during the school commute hours. Nobody could have expected this could be a point, but it was a long ache problem that we used to have, and these are things that makes a difference for a city administration. So that is how we actually go with these technologies. Okay, the next one is today, even though we talk about we are ahead in many cities and in many countries, again, there is still new development and difference of opinions happening for this implementation. Like developed countries being having a good infrastructure and a very, I would say, disciplined driving habits, they tend to come out with a more generic type of implementations, whereas countries having especially having a lot of two-wheelers, I would say, passenger cars or private cars, they are having a lot of difficulties in the administration, because the more the vehicle, the more the congestion, the more the people. So it is something not just technology, it's more on the what we call as the governance also. Again, the network, there is a big debate ongoing whether the network need to be a private network or it need to be a public network with implemented security. So that is another path that we are looking at also. And there is another technology, another standard that is being worked on. We call it the NCAP 2026 plus. That's a working name. So there will be a final name when it is actually launched. This is not just ensuring the safety of the vehicles, it is ensuring the safety of the entire ecosystem. It could be the infrastructure, it could be the pedestrian, it could be the vehicle itself, or even it could be the network itself. So that is what they are looking at it. So as I mentioned before, one topic that people are repeatedly now discussing is how to include moving vehicles or mobility into digital twins. Today, if you look at digital twins, whether in a building or in a campus or even in a city, it is more of static things, not about moving things. So a lot of development is going on that particular area also. So if you can imagine, it's like a game, like that's why I just choose this image to showcase to you, where integration of V2X, within digital twin will certainly add a very enthusiastic and interesting factor in this whole approach. And OCC is normally we call as operational command center or central command center, which is mainly we talk about managing, like we can say is a traffic control room in a city level or traffic control room in a city level. But again, as I mentioned earlier, the key thing is we tend not to design system just being passive. The systems has to be more of interactive, real time, and fast responding. So end of the day, it has to improve the overall activity, right? So when we do this, we need to have an unified protocol or a unified standard that is seamlessly adapted by every different manufacturer. So he should be what we call as a maybe a signboard hoarding manufacturer, or he could be a gate or a turnstile barrier manufacturer, a vehicle manufacturer. Any, it could be anybody. Even electric bulb can be V2X, that means V2I, because it comes under the infrastructure. So that is what we, so it's all about, we talk about connected systems. It's not about just connected vehicles, but it's also about is communicating. So we are talking about a connected world today. So what would be the potential impact that we are actually looking at it is like the first thing is a more cooperative and intelligent network. Again, there is a human factor, but it is very important because end of the day, if we cannot really enforce a certain habit in the driving or certain habit on the road, this will be always a dream and never comes to reality. But accident prevention, emission reduction, and flow increase, I think certainly we can achieve it for a certain period of time. That is possible. And again, as I mentioned before, we start a bit late, but that is also for good because we know what are the issues, what are the concerns. So I think we run about, we had a big plan in India for 100 smart cities, and most of them has been implemented, but that initial cities has some issues and concerns. Today we talk about connected smart cities where autonomous mobility may be a feature also. So but again, here in the technology wise, again what we see is only two factors. One is on the IoT and another one is on the network. If these two things can improve, and it is improving on a regular basis, so we may not know down the road 3 years from now, 5 years from now, what would be the speed and reliability better of the technology today we have for wireless communication. At the same time, we are sometime of the generations that we have seen a big computer in a building size. Today, we see computer in a digital watch, computing devices or IoT devices type of thing. So things are changing very fast, but certainly it is for the good. Sorry. So let me stop here to ask for any questions before I move to the next one. Please feel free. If I am too fast, I can go back to any slide also. You can type your questions in the chat box, or you can just unmute and talk also. Okay, we have a question. Is the BS6 standards taking care of this V2X in India? To some extent, I would say yes, because that is one standard that, because as a Commonwealth country, we are very adapted to it. But again, it doesn't mean that that is the only standard that we are following. Any other questions? Okay, let me move on. So today with this V2X, actually what we see is this would be the okay. We have a very interesting question. Yeah, if V2X comes into picture, who will own that network? So that is really a legality or regulatory question, I would say. So as we mentioned, right, there is two different approach or adoption of V2X is available. One is we do the V2V approach, where it is more of like what you see here is a peer-to-peer communication, where the communication is directly between two parties or two systems. In that particular aspect, you do not need anyone to own the network. This is what even many years ago, after some direct aeroplane flight crashes, it was used, and it has been very effective for flight travel, or we can say like a flight transport. So two aeroplanes, when they are in the nearest proximity, today they can actually communicate and automatically respond their flight also to a different opposite directions without just providing an alert or an alarm to the pilots. But now we are seeing it on the road, and we are seeing it in the city itself. So that is where the infrastructure comes into role. So the first aspect, it is okay, but the second aspect, certainly again there will be a service provider, there will be a spectrum in the ITS band or something that would be provided to this particular communication without interfering with any other spectrum also. And the TRAI would be the regulatory who will also approve this. And there will be also what we call as equipments that communicate in this spectrum has to be declared or adopted also, what type of technology, what type of methodology that they are using for these communications and all. So we will do it in a very gradual way, or in a very different phased manner, I would say. So new cities or smarter communities, it will start first, where things can be easily managed. Network can is the same like electric car, because many people have thought, right, electric cars when they are first introduced, people thought big countries cannot adapt to it because the charging is difficult, and we cannot find that type of situations. But today we see it is getting more common also. So the same thing will happen for V2X also, where we will see that more adoption will take place, but it would be certainly a
ఏమండి డైనింగ్ టేబుల్.
yes, in the newer cities that are being built, it is actually in the smart cities plan itself, and it is very futuristic. People include it because again we say it in the command and control centers. It will include it. So Amaravati is one good example. Yes, it is in the plan. And we have seen townships, a lot of industrial townships has been, because today we are not seeing what we call as a monotonous manpower standing on the road monitoring or managing things. So we also moving very fast, right? When we do, we tend to put technologies like automated lights, we put. So townships are the earliest adapters for this, and some city administrations are taking it a bit forward also. So again, it boiled down to the point just now, as I mentioned, end of the day, it is again, you need to have your V2X system from the individual. It cannot be silos. It has to be an ecosystem. So that is why we need the standard protocols or standard industry standards to be adopted by all these things. And that has to be seamlessly integrated with the command centers or the security or the operation centers of the cities. And that is only one part of receiving the information or receiving the alerts and notification. Depending on the particular city or township, there need to have a standard operating procedures response mechanism, so as in return the response instruction, response commands, response scenarios and procedures will be automatically sent back when it is received without waiting for a human intervention. So if you see next time when you're walking into any city, if there are kiosks, just for, if you see our signboards, high possibility there might be inside more of this communication V2X solutions that able to communicate around. Maybe not now, but in future, but the infrastructure is already getting ready. As I mentioned earlier, there is only two things that forms the foundation. One is the network and another one is the IoT or the device that you are going to put in. So V2X not necessarily just communicate between vehicles. It communicate between people, it communicate with infrastructure, and it is going beyond it. So we always look V2X as an ecosystem instead of a technology. So it would become a de facto standard also. We do not know, because the adoption is very varying in different parts of the world. But certainly it is an interesting direction that we all heading today. So having said that, do we have an improvement in the mobility in the cities with V2X in place? The answer is certainly yes. Do we prevent accidents? Certainly yes. But to what extent is the question. But certainly this is the way that we are looking at, no matter how what we say is how backward that particular city or country is. I have the privilege to travel to many parts of the world. I have seen even in Inner Mongolia, where people still live in ger, which is a type of tent type of thing. I have seen this type of technology. I amaze myself also, where they have a very strong communication backbone and all. So I think it's more always we are talking about enriching the lifestyle of the people. So we really see a very good forward action. But if you are focusing on any top, and then if I want to talk about the market size, if I am not wrong, it's about 20 plus or 32 something, more than that. The market size is near 20 to 30 billion in 2032. That is the market forecast that people are looking for the V2X services, V2X equipments, V2X research or whatsoever. So that is a clear sign that it is also an emerging area that we need to look upon. I think I am almost done with my presentation. So let me open the floor for the questions. Please feel free to ask any questions pertaining to this or in general ITS or smart cities. I would try to address it. You can just unmute your mic and you can ask, or you can just type in the chat box also. If you have any specific questions, please feel free. This is the time that you can ask. I don't charge for the questions. Okay, we have a question. How are unmanned vehicles that can communicate or take response or response to communication received? Okay, I think it's two questions in one. So first thing is unmanned vehicles usually so there is two parts, right? I will split that communication in terms of receive and respond. So so the first part is we receive communication or we receive data, right? So the first part, the receiving, I rather say it as sensing. Though sensing can be so first. So the question, let me put it into two separate questions. How are unmanned vehicles receive communication, and then how unmanned vehicles respond to communications? So the first question is the communication received for unmanned vehicles are not necessarily from external devices or from other vehicles or infrastructure. It could be from its own sources also. Like it could be sensors, it could be a satellite information, it could be a GIS data, geographical information system data, or it could be any other things. So all these things we talk about inputs. So these inputs has been, in terms of methodology, trained with a huge volume of data, assuming every possible scenarios. So if a vehicle is moving around in a city environment or a highway environment or a very cold, low voltage, low temperature environment, so all these scenarios, situations, possibilities, vulnerabilities, violations has been predefined. So, because as I mentioned, the response has to be very, very fast or instantaneous. So there is no time to think. You have to respond immediately. So to respond immediately, it must be a good and right response also. So when the response need to be right, you must have already have a standard ready methodology or procedure or answer to respond to that. So the first thing when receiving things, so that's why the capability of reception of input is very important. The more is merrier. So today with the connected systems, so it's not just the vehicle sensors we receive from other vehicles, other infrastructure in the road, we receive from satellite, other sensory devices also, and all this has been creating various operational scenarios inside the vehicle. And inside the vehicle you also have sensors. The engine is overheated, the tire is getting flat with less air, the fuel is getting whatever things. So everything has been already predefined. So there is, because end of the day it is a machine. So the machine is no matter better than human. The only thing the machine can do better is it is fast and has a huge memory. So that's why the amount of data it can process in a very fast manner, or the response that can do in a very microsecond or millisecond gap, is the real strength of equipments. So the response, how fast it will respond or how it will respond, is again is a defined lookup table that you can say in a very simple language, where which are the scenarios, what should be the response. So I can give you a very simple or a real example. I think most of you must be watching YouTube. So tonight, if you can go back and watch in YouTube, try to find the Boeing 737 MAX case study in US. So there were two fatal accidents. This was a new aeroplane launched by Boeing, maybe possibly 6 to 7 or 8 years, 7 years before. And it's called MAX is the extension. It's a small fuselage plane. What happened is there were two tragic accidents, one in Indonesia and one in Africa. And there is a lot of, let us leave the politics and regulatory things aside. But the gist of the message is it was a software glitch. So why it was a software glitch? Okay, somebody who has been handling this found it as not resolvable through the mechanical means or electronical means. So end up he managed to what we call as the buffer the data or surface the data or round the data, whatever thing, to compensate that imbalance. So what happens is when the plane is actually deviating or deflecting, the thrust is reducing, but the pilot won't see it in the indicator. So this is a manned plane, but let the pilot to take a wrong decision, which end up, I think, of both of this accident, we lost more than 500 or 600 over lives. So that is the biggest challenge, right? How you train the system or what type of response methodology is reliable. So here comes the role of regulatory. So to take response, what response is it, an approved response, right response, and does it really proven? So that is the key thing. I hope I answered your question. Thank you. We still have 15 minutes time. Any other questions, please? Again, to add on today, what you have seen is just, I won't say like it's a complete thing, but I believe that it would have given you some sort of insight into how things are going around in this particular topic. And this is continuously evolving, and we are also catching it very fast. So we cannot say that this would be the fixed technology forever, especially with the wireless communication arena that is increasing fast. We are seeing big changes, and now data center is another thing coming up with a different type of data center, and data is becoming the new oil. So things may take a very interesting direction in the near future. Okay, any other questions? If no other questions, I will share my contact information. This we can take a picture of this. And if no other questions, thank you very much for your time and attention. Feel free to contact me if you need any information or guidance. I also thank Hitam for giving me the opportunity to share this with you guys. Thank you.
Thank you so much, sir, for your time. And thank you so much for giving this such a wonderful session. Thank you.